Hello and welcome to Techie Hive. In this video, we will talk about another top Java interview question related to Java application troubleshooting, and question is on the screen. A Java-based microservice performs well immediately after the startup, but over time, its response time degrades significantly, and eventually, the service becomes unresponsive. How would you troubleshoot this application and identify the root cause and the solution? So by asking this question, interviewer wants to understand that you understand how to debug Java application when it's in production environment. Let's go to the answer of this question. This is a classic microservice degradation over time problem, usually caused by resource leaks, GC pressure, thread contention, or downstream dependencies. This strongly suggests something accumulating over time, and it's not a sudden failure. Typically, typical suspects could be memory leak, thread leak and thread contention, connection pool exhaustion, excessive GC pauses or GC pressure, downstream dependencies, slowdown, blocking calls in a non-blocking system. So these could be the reasons of the slowing down the application, because application runs fine when it starts, and after that, as time passes, application becomes unresponsive or very slow. So that means something over time is accumulating. Let's see how these affect the application performance. And first, we'll talk about memory leak. So memory leak symptoms are heap usage steadily increases, full GC becomes more frequent, garbage collection pauses get longer, and eventually out of memory, or there is a long stop the world pause. So these are the symptoms of memory leak, and to confirm them, we can use uh, Java profiling tool, and GCMD is one of them. So first, what we can do, we can enable the GC logging, and by enabling GC logging, we can just observe the logs and see what's going on for the garbage collection. Next, take heap dump when memory is high. So observe the memory, and when memory is high, take the heap dump using GSMD command again. And once you have the heap dump, then you can just analyze the heap dump by uh, Java Mission Control profiling tool or any other heap analysis tool like Eclipse Mat, and you can find out what all objects are accumulating and why they are not getting freed. And the common causes are static collections holding data. Sometimes we use large number of static collections in the application, and they increase the memory size because they are not collected by the garbage collection. Caches without eviction. So sometimes we use cache in our application, and we generally forget to define the eviction policies. So caches should be defined with the eviction policy so that they are cleaned once used. Listeners, not deregister. Sometimes we use listener objects in our application, and we register them with the application, but they are not deregistered. So this could be the reason that listeners stay in the memory for a long time. Thread locus not clear. So sometimes we use thread locals to define the thread specific data, but sometimes we forget to clean them. So remember, whenever we need a thread locals, so we need to clean them. So here you can see thread locals are not clear. That will be the reason of the memory, memory pressure. Large object written by reference. Sometimes we create a very large object in our application, and because of that, if they are referenced by different, objects, so they will stay in the memory and will increase the memory size. So generally, we have to just check if there are any large objects in the application. How to fix them? Add eviction policies for the cache. So as I mentioned here, the cases like we have to define the proper eviction policies for the caches, and you can use any caffeine or Redis, any other type of cache, and define the proper caching policies. Remove static state, so avoid using the static data in our application. So use static only when it is not possible using the non-static data. Clear thread locals, yeah, if you have thread locals, so don't forget to clear thread locals and use weak references in the so for cache, you use a weak reference because they are only collected by garbage collection when memory pressure is high. And also remember creating the small objects so that objects scope can be limited and they can be cleaned easily from the memory. Let's move to the next cause, thread leak or thread contention. So the symptoms of thread leak and thread contention are thread counts keeps increasing, requests start waiting, there is long wait for the request, service appears available but doesn't respond. Seems service is online but it's not responding to the request. So to confirm that, check thread count over time. So here, if thread counts are increasing over time, that means something wrong with the threads. And take a thread dump using JSMD command, and you can just use process ID to create the thread dump on fly, and just use the thread dump for further analysis. Look for many threads in the block state or writing state. Check how many threads are in block, blocked or waiting state. Sometimes it happens like there is a deadlock and threads are waiting for each other. CB might be ideal while threads are waiting on the lock. Analyze thread dump using Java Mission Control or any other heap analysis tool like at least Met or Medium. So check to find out the deadlock or number of threads in block state or waiting state. Use the Java profiling tool like GMC or any other tool and see what's going on for the threads. And common causes of thread leak and thread contention are executor service not shut down. Sometimes you use executor services and we forget to shut down them, and because of that, all of the threads remain alive. Creating threads manually. Sometimes we use thread class to create threads manually, but we forget to manage them properly. So it is recommended to use thread executor service for creating and managing thread. Unbound thread pool. Sometimes you use the unbound thread pool, and because of the unboundness of the thread pool, it increases infinitely. Scheduled task never cancelled. So sometimes we schedule a task, but it's never cancelled. Thread local never deleted. Yeah, we have thread locals in our application, but they are not deleted. Excessive synchronization. Sometimes we use excessive synchronization for the synchronizing the resources, and because of that thread leak or thread contention happens. Blocking code in async or reactive code. Sometimes we use blocking code in async or reactive code, so we should avoid blocking calls in the async or in async reactive code. How to fix them? Use bounded thread pool and shut down executor services. So as I mentioned that when are you going to use threads, then use a bounded thread pool and use the shut down executors. Use concurrent collections. So instead of using the normal collections, use concurrent collections because they manage the threads automatically. So there is no need to synchronize the threads manually. Clear thread locals. Yeah, it's obvious we need to clear thread locals so that thread size you know will be less than the what is expected. Use non-blocking asynchronous patterns. So like when we are using asynchronous calls or asynchronous pattern in our application, and don't use blocking calls. So use always non-blocking and add timeouts to all action calls. So remember, add timeouts to the all of the calls so that thread is not waiting for infinitely. Let's discuss the other causes. Connection pool exhaustion. Sometimes we create a very small connection pool, and when we have the connections more than the size of the connection, then the threads are put in the hold. So they will increase the number of threads in the memory. Excessive GC pauses or GC pressure. Sometimes there is a long GC wait, and all of the threads are waiting for GC to complete. So that will increase the number of threads in the application to wait. So that can cause the slow down the application. Downstream dependence the slow down. Sometimes we have connected to the downstream applications, and if a downstream application is slow, then our application will wait for long time to get the response, and that it will increase the application wait time. So if we have any downstream application, then we have to special time out for that. And then blocking calls in non-blocking system. So we should avoid using blocking code in non-blocking system. So if we have any reactive system, then in that case we don't use any blocking call as a part of that system. Okay, that's all I wanted to cover in this video. Hope you like it. See you in next video.